Okay. So like I said to you guys, the learning goal is on the board. Very specific task. As you can see, I'm trying to change the function, the trig function that is written in two pieces, a cos x plus b sine of x. And you will see a lot of variation of this when we do the exercises, into a trig function of compound angle on the right-hand side. Yes? And we've seen these before. So what I'm going to do, I'm going to write down our learning goal first. So up on the projector, everything's set up. Hopefully this works this time. Learning goal is that you will be able to the reason I'm rewriting this learning goal is because I will scan these lesson notes and I will leave them on the ELAN for you. Express trigonometric trig functions in the form of trig compound angles. Okay. And the reason that this task is specific is because we're going to move from the form of a cos x plus b sine x into d sine x plus c. And this c obviously could be replaced by theta, alpha, beta, whatever you guys decide. Yeah? Good. All right, these are just parameters. Some books show this by r, so this is interchangeable. If you have r here, and everything else could be different letters, obviously, as you can imagine, with algebra. All right. So before we get on to it, I would like to quickly and very quickly go and have a quick review of our Pythagorean identity. So I'm just going to write here a quick review of Pythagorean identities. And we did these identities. We actually practiced these. We actually practiced these last term, if you remember, yes? We had the most famous one I've had was sine square theta plus cos square theta, and that was equal to 1. Tangent square theta plus 1 was also secant square theta. The last one, 1 plus cotangent, equals to cosecant square of theta. And you saw last year that we derived all these formulas, the rest of them, from our unit circle, right? When I had this relationship established, correct? Then I could just basically go ahead and manipulate this equation and find these other ones from it, correct? Now, these were the identities, the very basic identities. There's many other identities as well that we're gonna have to make ourselves familiar to. Okay, these identities will be given to you in the exam. You do not need to remember these identities. I will tell you which one you do need to remember. All right, so these were the identities, and on this side, if you remember again from last time, we had the trig addition theorems, right? And again, these we could actually go, it's a very lengthy process of proving these things. Plus minus y equals cos x cos y, and plus minus, and be very mindful of the order of the plus and minus. Yes, so obviously if you have cos x plus y, this will correspond to cos x cos y plus You see where the signs are? They correlate. Good. So, and then on the other side I had sine x, sine y. Yes? This was one of them. Another one we had was for sine. So we had x plus minus y equals, same story. You had, what do we have? Sine x cos y. Was that plus minus or was it minus plus?
Minus plus.
Minus plus? Very good. So minus up the top, plus down the bottom. And I have over here sine, cosine x, and sine y. Very good. And last one but not least one was tangent, correct? Tangent of x plus y plus minus y equals, and over here tan x plus minus, that corresponds to that sine. And down the bottom, what happens here again? Was that one minus or plus? Minus plus.
I know.
Yeah?
I don't think we actually did that.
You never remember that. That's fine. Tan x and then tan y. Now, these are the ones, these two. This is obviously the double angles. And you can see in our learning goal, the setup right here, the sine of x plus c is the one that I'm going to be using. So it's right down the bottom here, correct? These addition theorem as well as the Pythagorean identities will be provided in your exam. You do not need to memorize these, but you do need to be able to work with these. If you need to change or manipulate an equation, that means you need to have enough practice with these as much as you can until you familiarize yourself. But the fact that I don't need to remember these, that's a bonus. Yes, Maria?
Why is the sign flipped so it's minus?
Because if we go through the proof process, that's what happens. All right? Okay. Like I said, don't have to remember these. Okay, very quick review. That was good. And the last one, if you want to, just as a quick reference, I will write the multiple angle formula for you as well. That we have it just on our head. So sine 2x, and this is easy to be derived from this formula anyway, because if I substitute y as an x, right, then I'll end up with sine 2x, and as I substitute everything else there, I will end up with 2 sine x cosine x. Good. And down the bottom here, I have cos 2x will equal to cos square x minus sine square x equals, and exactly the same thing I was talking about. You can manipulate these to have different variations of it. I can say, well, instead of cos square x sine square x, I can write sine square x as 1 minus cos square theta or x. Therefore, I'll end up with 2 cos square x minus 1 when I simplify my equation. Or another variation is that 1 minus, maybe I should write it underneath, so you guys can see that these are all the same thing. So that equals to 2 cos square x minus 1, and that equals to 1 minus 2 sine 2x. Okay, very good. All right, so this will be provided for you. Beautiful. Cool. Just need to do one thing before. I apologize. I need to stop this video for a second, guys. Okay. I will cut this bit out later. Yeah? Okay. So let's go ahead to our concern. Learning goal, our actual learning goal. So, draw a line here. I'm going to reference back to the fundamental of trigonometry. And if you guys remember, I'm sure you will, the fundamental of trigonometry came from a right-angled triangle, correct? If I have a right-angled triangle, these whole cosine, sine square, and everything else came about from a right-angled triangle. Excellent. So I'm going to go start just very quickly label this triangle, and could my lovely year 12 math C students tell me that how do I find the Pythagoras of this right-angled triangle? What is the quantity? A squared, B squared, and then square root. Beautiful. So let's just, for the sake of the argument, I call this angle alpha, this angle beta. Sweet. Let's begin, huh? What am I going to do? All right, we're going to start with that side of my equation where I had a cosine x plus b sine x. Very good. Okay. Now, this is going to be, like I told you, it's a specific task that we're trying to conduct here. So, what it means is that I'm going to be doing things to this equation that might not be exactly, you say, okay, why are we not doing something different? Okay, but we will down the track find out that how useful that was for us. Okay, so what happened with the mathematicians, they've worked backwards. They've worked from this side, expanding this equation, and to get to the other side, what we're doing, we're going to follow their work the other way around. Okay, does that make sense? So that's the reason I'm going to do this over here, and I want you guys to tell me if this is going to actually change my equation at all, yes or no. So I'm going to grab my hypotenuse, the length of my hypotenuse, and I'm just trying to make sure that it's in the frame, and multiply a squared plus b squared down up the top and down the bottom, multiply this fraction into my equation, which is a cosine x plus b sine x. Did that equation, did this operation, is it going to change anything in my equation? No, because this is just the one I'm multiplying, correct? Very good. So now let's go and see how this is going to become useful for us, right? So from the distributive law, I can easily see that if I leave that square root up the top out of this bracket, and I take in this square root up the top. And the reason for that, I should have probably referenced here, but I want to show you that how this works first, and then I reference it here to our triangle so you guys can see. So let me just have my triangle here. All right, good. So let's get started. Let's do this now. I want to go ahead and take the denominator in, leave the numerator out. So I got a squared plus b squared brackets a over square root of a plus b squared, a squared plus b squared, cosine of x, right? I'm distributing this, right? Plus b over square root of a squared plus b squared sine of x. Very good. Did you see what I did there? I just distributed this into this, so I multiplied that by that. Then I multiplied the same with that using the distributive law or the foiling, expanding the brackets, right? This is what I ended up with. Now, this is really good for me because I'm going to have to move this here. And I think some people have already seen the relationship, right? In a right-angled triangle, everyone knows, since we are working in that right-angled triangle up here, everyone knows that cos, by definition, right? By definition, I have sine of alpha. Let's say sine of alpha. What is sine of alpha? What's the definition? It's opposite over hypotenuse, isn't it? Isn't it? There you go. This is alpha, right? This is my opposite side. This is my adjacent side, and that is my hypotenuse. Therefore, sine of alpha is opposite a divided by the length of the hypotenuse. So hypotenuse is a squared plus b square square root of that, correct? Cos, similarly, can be written as b adjacent side, right? Adjacent side divided by a square plus b square square root. Good. Well, if that's the case, what is the tangent of alpha? Isn't that just opposite over adjacent? So I can write it like that. There you go. Beautiful. So these are the relationships that I didn't invent. I just used from that right angle triangle. Good. Okay, well, let's see what I can substitute in that equation, in that expression up the top. Right, up the top, so I can start working with this thing. Very good.
You must use the either the alpha or the beta. You can't have one
Very good.
because, yeah.
Very good, very good. And I'll get down to that. Very good question, yeah, Noor? I will get down to that we're going to be working with one angle at a time. Yeah? All right, cool. So far, I started from here, right? Look, I've started from a cos x, b sin x. I'm going to say, well, therefore, where we started from was a cos x plus b sin x equals, right now I have this term, right? I'm going to move it up so you guys can see this one. Right now I have this term, well, I'm going to write it there, is a square plus b square into the bracket of, well, a over hypotenuse is just, who said sin? Did you say sin or sine? Sine. Sine. Oh, is that just to make me angry? That's right. I remember that. Yeah, that's okay. Okay. So sine of alpha is a over hypotenuse, and I have a over hypotenuse. I can substitute that by sine of alpha. Very good. And I have what left? Cos x. Very good. Cos x plus b over hypotenuse. Well, b over hypotenuse is nothing but cos alpha. There you go. Cos alpha, and then I have sine x. Excellent. Perfect. Very good. It's coming about, huh? Okay. Now, does this look anything like familiar to you at all? Where have we seen this before? Yes, Josh? Sine of? It is a sine of double angle. Excellent. What double angle is this? X minus? X minus or X plus? Okay. If that's the case, then Mr. Seitz. Yeah. Plus, minus. Fix that one. Up the top here. Okay. All right, back to me again. Up the top here, sine x plus minus y corresponds. Yeah?
So just one second, I'm searching right now.
You're searching it right now? That's fine. I'm going to carry on. Okay, let's see. Down here, I'll end up with x. Well, it's sine of x. It's a double angle, and the angles I have is x and alpha. Very good. I can substitute it by that. And at the back here, a square plus b square stays the same, right? Hang on, hold it. Okay, there you go. Okay, well, that's a nice little expression, isn't it? And down here, what I have is just, I'm going to box this thing, so cos x plus b sine x equals that. Isn't that what I was actually trying to achieve with our learning goal? Okay, this is our learning goal, right, up the top. Right there, I had this form, a cos x plus b sine x sine x equals, well, it was d sine And let me just write it right underneath it so you guys can visually see what is what. So down here is d sine of x plus c. Wasn't it? Wasn't it? Very good. Well, if that's the case, then I can define each one of these parameters, right? I can go ahead and I can say, well, in this case, d equals square root of a squared plus b squared, right? I can see it, correct? X is just x, alpha is c. I told you that c could be replaced by any letter if you want to. And there you go, I'm done. But what is alpha? Because I need to find alpha, right? So, well, we do know that we have relationships for alpha. We have sine, we have cosine, we have tangent, correct? Well, if I wanted to find alpha, well, I do know that the tan of a over b, opposite over adjacent, equals that angle, doesn't it? Doesn't it? Well, if that's the case, then I can easily find alpha by tan inverse of a over b. There you go. I have this. I have this. I have these items over here, and everything could be translated into this little double angle formula, right? So that's one of them. And what Noor was talking about was that if I wanted to use beta or beta over here instead, well, how would that change? Actually, you need to know that one as well. Similarly, same process happens. I'm not going to go through the whole thing, but again, I would just write here similarly, we're going to have a cos x plus b sine x equals to my hypotenuse a squared plus b squared square root times a over square root of a squared plus b squared cos x plus b over square root of a squared plus b squared sine x, right? This is what we had, correct? In that case, what I want to do here, look, this might be actually a bit simple to see b over that. Okay, so over here, in my triangle, all right, I just want you guys to see the triangle while I'm doing this, so I might do this. Okay, so the triangle is up there, all right, good. That's not going to fit. Okay, put it next to it maybe. Yeah, okay, well down the bottom here, what I have is a over a squared plus b squared, right? I want to write this for beta. Yes, move it up a little bit. To the side, like this. Is that good? Yeah. All right. Well, guess what? The same way I wrote trig relationship for my alpha here, I can do the exact same thing for beta, right? What is the sine of beta? Well, by definition, sine of beta or beta is sine of beta is b over, because that's the opposite now, right? Look, b over my hypotenuse. This is the opposite now. Very good. Well, b over hypotenuse can be written as what? Sine of beta or beta. Therefore, sine of x. Cool. Well, similarly, same situation happens here. If I want to deal with angle beta, I can say adjacent of beta, which is a over hypotenuse. Adjacent of beta over a. What is adjacent over hypotenuse? Cos. Beautiful. So this is actually cos of beta, cos of x. Perfect. I have this little thing here. I have this little thing here. I'm going to leave them in there. And guess what happened? we have another beautiful relationship, another beautiful equation, cosine of x plus b sine of x equals this little thing here. And the only thing is that when I go ahead, and again, once again, does that look familiar to you?
Yes, the cos.
This is the cos, right? And when I go over here, okay, I think I found our mistake.
So your mistake is
I think I found our mistakes.
messed up the cos.
Yes, I messed up the cos, thank you. So over here, it needs to be changed. All right, everyone go back to your trig addition theorem. Minus and plus. Okay. Yes? You're the one that you wrote in the beginning of the lesson, yeah? This is where I messed up, right? Look. That's the cos I messed up, not the sign. So the sign was fine.
Wait.
But the cos need the opposite. So up the top you have positive.
Change that to
Very good. Positive to a negative. And a negative to a positive. Opposite. Good. Yes, you got it? Good. Wait. Oh, good? Yeah. Look. Do you see where my pen is?
this one would be a negative.
Positive, negative. Over here, negative, positive. That's what I want to change. That's fine. That one is fine. Okay, cool. And let's number this page 1 so I can scan it for you. Okay, back to me again, and we are almost done. We are almost done. Fair enough. So now again, I have this little relationship over here. Like I said, which one of these is this any familiar to you at all? Well, obviously cos x cos y, sin x sin y, cos beta cos x, and sin beta sin x is going to be related to cos. And because there is a positive over here, very good, it will become negative. So if I wanted to write that as a double angle, I have this thing, hypotenuse plus b squared times cos of x minus beta or beta. Right? So on the other side, I have a cos x plus b sine x. And this little tiny, very useful relationship is what's going to help me pass my Math C test, right? And I'm going to number that number 2. Very good. So these two, this one down the bottom, and I wrote them far apart from each other, that one up the top and this one down the bottom, are the ones that you need to know by heart. Because it was easy to derive it, right? It took me about 20 minutes with a lecture, maybe half an hour, but if you do it on your own, probably it's going to take you 5 minutes, right? It's easy to derive when you know your trig ratios and when you know your double angles, but that's not what you want to do in the exam. Sure. Okay. Well, I give you an example of this. So with these ones, obviously, as you could see, with the first one we had, I found alpha, right? I found that it's tan inverse of A over B. So it's similarly, over here, I have all these parameters that I can define. Well, with this one, I can say where tangent of beta equals a B over A now, right? Because tangent is opposite over adjacent, which is, look, for beta is opposite over adjacent, so it's B over A. And if I wanted to find beta, it's simple because I can go tan inverse of B over A. Done. Good? Cool. Let's do an example. Everybody with me? All good? Example number 1. Express 3 sine x plus 4 cos x in form of this form. D sine x plus c. So once again, you have a trig function, right? Trig function. well, I should say two trig functions, a combination of trig function. So I said trig function. Down here you have the compound trig form or trig function, right? Compound trig form. So I want to move from this form into this form. And in case you're wondering what's the point of doing this whole thing, is because when we move to our next example, they will ask us to solve an equation. And if you don't know how to do this, how to transform this form into this form, it's going to be tedious for you to solve it. Okay, cool. All right. Well, let's do this together. You can start, have a go, and see how this one turns out. At the same time, I'm going to walk with you. So I'm going to write the whole thing again for our reference, right? So we do know that. So I say just we know. And in your exam, in the test, or wherever you're going to be using this, it's very useful for us to, first off, write everything that you were supposed to remember on a piece of paper or on your exam paper. Just have it on the side in case you get stressed, you're running out of time. Make sure that you write this first thing in the exam, the things that you needed to remember, right? So I'm going to write this for myself, a quick little note here. Sine of x equals, well, square root of a squared plus b squared. My plus is a bit distorted. Fix that one. Equal, sine x plus alpha. And over here, where I know that the tangent of alpha equals what? A over b. That's for when I have a sine, relates to tangent. When I have a cosine, which is the same exact, I can say or, I have these two, right? Cosine of x plus b sine of x equals, again, the same story, right? A squared plus b squared, this time is cos of x minus or plus? Minus which angle? Beta, very good. So over here, excellent. And where I know that tangent of beta is the opposite of tangent of alpha. So it's just going to be b over a. Correct? So these two little side notes. Cool. Good. Well, that shouldn't be hard. Why is that? Because, look, I can just go through my equation one by one and identify each parameter, right? So if I write it out, I say, okay, well, this is 3 sine x plus a 4 cos x. Yeah. Yes. Hang on. It doesn't look like any of these, does it? Does it? Does it? It might need a little tiny rearrangement. See, this one has got cos first. There's no cos. Maybe I can easily go, okay, well, 4 cos of x. No, nobody's going to die if I do this, are they? See, sine x. Right? Now it looks like what I'm familiar with. Yes or no? Good. Well, there you go. I have this little thing here. One by one, I'm going to identify my parameters. Well, what are they? Well, over here, I can see right up the top, I'm dealing with, well, whichever I decide to work with. This one, a equals what? Here. What is a? Very good. 4. What is b? 3. Very good. So if I have 4 and 3, I'm able to calculate the tangent of alpha, right? Or beta if I want to. Subsequently, I can calculate the angle itself, right? Because I know alpha equals what? Tangent of tan inverse of a over b, right? A over b. So a over b is over here. What is it? It's tan inverse of a is 4 and b is 3. Excuse me, right? Very good. Well, I need to calculate this, and I will calculate it in a minute. I go, okay, well, let's do tan inverse of, get rid of this, tan inverse of 4 divided by 3. Okay, good. So the angle that is giving me, and make sure that you are in degrees for this. Yeah. So this is actually 53. When I say you make sure you are in degrees, I'm talking about your mode, yeah? Your calculator mode.
Oh, it actually needs to be
You have to be in degrees, yes. Because you're calculating an angle. It's an angle.
Oh, yeah.
Right? Okay, good, good. Cool. All right, let's go back. So it was 53 point, whatever it is, like 30 degrees. It's an approximation. Okay, good. Perfect. So I have that, I have this, and I have that. What else do I need? Well, I need D, right? I need that, the one that goes behind the cos or sine, this quantity. Well, that's easy to calculate. That is actually square root of a squared plus b squared. A squared plus b squared. I'll finish this and then I'll attend that task, yeah? So 4 square plus what is b? 3 square all right. So I found my angle. Excellent. Quantity of a squared plus b squared square root can be easily calculated by this. So that's 16 plus 9 is 25. 25 is square root. What is it? 5. Perfect. That will become my D, correct? All right, excellent. I have this, I have this, I have this, I have my angle. All I need to do is a substitute, simple substitution, right? Which we decided to go by sine of x plus alpha because we calculated alpha, right? We said A tangent of alpha is A over B. Again, if you decide to go with the other one, but the question did ask you to use this form, right? They didn't give you an option. Therefore, we had to go by that anyway. So just disregard what I just said. But it works the other way around. That's what I'm trying to say. All right, well, perfect. Well, this one now becomes 3 sine x plus 4 cosine x equals, what does that equal to? Well, I'll go grab my format, D, which is 5, perfect, times sine of x plus what angle? 53.13. I'm done. Okay. Good, good. So we leave this up the top here for you as a reference. I think I have explained it quite well out of habit, you know, as I do. I'll have another example for us here. Then we're going to be very quickly transit into solving one equation. I want you to see how the equation is solved, and then I'll leave you to do your worksheets, okay, if you have energy by the end of that. Yes?
When you write the final answer, you put the sign of degree x plus.
Oh, yeah, you do. You're supposed to, yeah. What, here? Yes. Yeah. Bad teacher, huh? Okay, well, example 2 is the same situation. Express 2 cos x plus 3 sine x in the form of, now this time I'm going to use sine again, right? Sine x plus c. Sometimes, now this is the key, right? This is the key. In these type of questions, they might not tell you that you need to write it in this form. All they're going to tell you is the generic form of a compound trig form. That means your hand is open to choose which one you want to go by. You want to go by this format or you want to go by that format. But hopefully, they will restrict your options because more option doesn't usually mean happiness, right? Right. Okay. All right. So you guys go ahead. I'll wait until we do this one together after, and then I'll tell you how to solve an equation. This should be simple enough. Yeah, I'm going to stop the video. When that gentleman comes back, I can deal with him.